During the Second World War, Nazi Germany developed and deployed an enormous variety of weapons. Some were based on existing technology, while others represented some of the most advanced military innovations of their time. On the battlefield, Allied soldiers encountered German weapons whose reputations could sometimes spread much faster than accurate information about their actual capabilities. The extraordinary rate of fire of the MG-42, the heavy armor and powerful 88mm gun of the Tiger tank, and the threat posed to armored vehicles by the Panzerfaust made these weapons famous on different fronts. But Germany's arsenal was not limited to warfare on land. In the Atlantic, German U-boats attempted to cut the maritime supply routes that were vital to Britain's survival. In the skies above Europe, Luftwaffe aircraft participated in some of the largest aerial operations of the war. During the final stages of the conflict, Germany also deployed the V-I and V-II weapons, offering a glimpse of how long-range missile technology would develop in the decades after the war. Not every famous German weapon, however, was as unstoppable as its later reputation might suggest. Some suffered from technical problems, high production costs, enormous fuel consumption, or production numbers that were simply too small. Some were tactically effective but were never capable of changing the ultimate outcome of the war. In this video, we will count down from 10 to 1 through 10 of the most famous and feared German weapons and weapon systems of the Second World War. We will examine how they worked, where they were used, how effective they really were, and why their reputations have survived for more than 8 decades. The list includes everything from weapons carried by individual infantrymen to heavy tanks, flying bombs, ballistic missiles, and submarines hunting beneath the surface of the Atlantic. We begin at number 10 with a weapon that appeared on the battlefield during the final stages of the war and whose basic concept would have a major influence on the development of infantry weapons that followed. Number 10. The Sturmgewehr 44. Number 10. The Sturmgewehr 44. During the final years of the Second World War, a weapon began appearing in the hands of German soldiers that looked very different from traditional infantry rifles. It was the Sturmgewehr 44, better known as the STG-44. Although it arrived too late to change the outcome of the war, the concept behind it was significant. The STG-44 combined characteristics that had previously been associated separately with rifles and submachine guns. At the beginning of the war, the principal rifle of German infantry was the Karabiner 98K. It was a reliable and powerful bolt-action rifle chambered for the 7.92A 57mm cartridge. It could engage targets at long distances, but after every shot the soldier had to operate the bolt manually. At close range, the situation was different. The Germans also had weapons such as the MP-40 submachine gun. Its automatic fire provided considerably greater firepower at short distances, but its pistol caliber 9x19 millimeter ammunition limited its effectiveness at longer ranges. There was an obvious gap between these two types of weapon. The Germans had recognized that much infantry combat occurred at distances, where the long range offered by a traditional full-power rifle cartridge was not essential. The solution was the shorter 7.92 33mm Kurz cartridge. It was less powerful than the full-sized rifle ammunition used by the Karabiner 98K, but considerably more powerful than a typical submachine gun pistol cartridge. Around this intermediate cartridge, it was possible to build a weapon that an individual soldier could control in both semi-automatic and fully automatic fire. German manufacturers, including Heinel and Walter, were heavily involved in the weapon's development. Hugo Schmeisser was a central figure in Heinel's design work. During development, the weapon was known under several different names. Early versions were designated Maschinenkarabiner 42. Later designations included MP-43 and MP-44. Eventually, the weapon became known as the Sturmgewehr 44. The word Sturmgewehr can be translated approximately as assault rifle. The term would later become the commonly used name for an entire category of infantry weapons. The STG-44 used a detachable 30-round magazine. The soldier could select either semi-automatic or fully automatic fire depending on the situation. On semi-automatic, The weapon could perform many of the functions of a conventional rifle at typical infantry combat distances. When the enemy moved closer or greater firepower was suddenly required, the soldier could switch to automatic fire. This combination was the defining feature of the STG-44. A soldier no longer necessarily required a long-range, full-power rifle to fight effectively at ordinary combat distances. At the same time, his weapon offered greater range and power than a submachine gun. The STG-44 had a cyclic rate of approximately 500 to 600 rounds per minute. Loaded, the weapon weighed more than 5 kilograms, so it was certainly not particularly light. Its 30-round magazine was also large and strongly curved. Nevertheless, the reduced recoil of its intermediate cartridge made the weapon easier to control than an automatic weapon firing a full-power rifle cartridge. The STG-44 was seen particularly on the Eastern Front, where German forces were fighting the enormous armies of the Soviet Union. During the final stages of the war, it also appeared on other fronts. Its importance was, primarily, the firepower it placed in the hands of an individual. Infantrymen. Imagine a German unit defending a village or ruined city in 1944. A soldier armed with a traditional bolt action. Rifle could fire accurately, but after every shot he had to manually cycle the rifle's action. A soldier carrying an STG-44 could instead fire several aimed semi-automatic shots in rapid succession and switch to automatic fire when necessary. At close range, this could provide a considerable advantage in firepower. Unusual accessories were also tested with the weapon. The most famous was the Krummlauf, a curved barrel attachment intended to allow firing from behind cover or from an armored vehicle without requiring the shooter to expose himself to direct enemy fire in the same way. The idea was impressive, but the system had serious practical limitations. The stresses placed on the curved barrel were enormous, and its service life was short. It remained an unusual footnote in the history of the STG-44 rather than something that transformed ordinary infantry combat. The Sturmgewehr 44 has also become surrounded by myths that developed after the war. One of the most common concerns, the AK-47. The STG-44 and AK-47 have a degree of external resemblance, and both follow the broad concept of a selective fire infantry weapon using an intermediate cartridge. The STG-44 contributed to the post-war interest in this category of weapon. The AK-47, however, is not simply a copy of the STG-44. Their internal operating mechanisms and engineering solutions differ significantly. The true historical importance of the STG-44 is greater than such a simple comparison suggests. It demonstrated in practical combat use how effective the combination of an intermediate cartridge, a large magazine capacity, and selective fire could be in the hands of an ordinary infantry soldier. After the war, this basic concept became one of the most important directions in the development of modern military small arms. The STG-44 nevertheless had significant limitations. It arrived too late. By the time it began reaching German forces in larger numbers, Germany was already in an extremely difficult strategic position. The Soviet Union was advancing from the east, the Western Allies had landed in France, and German industry and transportation networks were suffering under continuous bombing. Germany managed to manufacture hundreds of thousands of rifles belonging to this weapon family, but this was not enough to replace all of the Wehrmacht's older infantry weapons. Producing and supplying a new type of ammunition to the front also created additional logistical demands, and no new individual rifle could solve Germany's much greater problems: shortages of fuel and raw materials, enormous manpower losses, and the growing Allied superiority on the ground and in the air. The Sturmgewehr 44 was therefore not a miracle weapon. It did not save Germany, and it did not change the course of the war. Technologically, however, its importance was considerable. It demonstrated what the future weapon of the ordinary infantry soldier could look like: a compact weapon, a high-capacity detachable magazine, an intermediate cartridge, semi-automatic fire for more deliberate shooting when required, and automatic fire for close combat and suppressive fire. Today, These ideas seem ordinary. In 1944, combining them in a weapon intended for large-scale combat service was far more significant. That is why the Sturmgewehr 44 earns its place on our list. It was not Germany's most destructive weapon, nor was it the most influential weapon system of the war itself. But for a soldier facing an enemy armed with an STG-44 at close range, the firepower it provided was very real, and its true legacy became even clearer after the war, as armies around the world increasingly moved toward the same basic concept. Number 10. The Sturmgewehr 44. Next, we move to a weapon that gave an individual infantryman the ability to pose a deadly threat even to a heavily armored tank. Number 9. The Panzerfaust. Number 9. The Panzerfaust. During the Second World War, tank armor became increasingly powerful. For infantry, this created a serious problem. Without an anti-tank gun or another heavy weapon, an ordinary soldier had very few options for stopping an approaching enemy tank. Germany developed a simple but extremely dangerous solution to this problem. The Panzerfaust. The Panzerfaust was a German disposable anti-tank weapon designed to give an ordinary infantry soldier the ability to destroy or seriously damage an enemy armored vehicle at short range. Its operating principle was very different from that of a conventional rifle or gun. The Panzerfaust consisted of a simple launch tube carrying a large anti-tank projectile at its front. The projectile's warhead used the shaped charge effect to penetrate armor. A shaped charge did not primarily depend on extremely high projectile velocity. The shape of the explosive charge concentrated its effect into an extremely powerful jet capable of penetrating thick steel armor. This allowed a relatively small weapon carried by a single soldier to pose a serious threat to a much larger tank. Development of the Panzerfaust took place during the war as German forces encountered increasingly large numbers of enemy tanks. The first model to enter widespread service became known as the Panzerfaust 30. The number approximately represented the weapon's effective range in meters. 30 meters was an extremely short distance. It meant that a soldier using the Panzerfaust had to allow an enemy tank to approach dangerously close before firing. This made the weapon effective, but also extremely dangerous for its operator. Improved versions followed, including the Panzerfaust 60 and Panzerfaust 100. Their sights, propellant charges, and effective ranges were improved. The Panzerfaust 60 became one of the best-known and most widely used versions. Its nominal effective range was approximately 60 meters. The Panzerfaust 100 could operate at around 100 meters. Although these distances remained short compared with dedicated anti-tank guns, they made the weapon considerably more practical than the earliest versions. One of the Panzerfaust's greatest strengths was its simplicity. It was not designed as a complicated reloadable weapon. Once a Panzerfaust had been fired, its launch tube could be discarded. This allowed relatively simple and inexpensive mass production at a time when German industry was suffering increasingly serious shortages of raw materials and labor, as well as major transportation problems. The weapon was also simple enough that a soldier could be trained to operate it relatively quickly. Using it in actual combat, however, required courage. Imagine the Eastern Front in 1944. Soviet T-34 tanks are advancing toward a German defensive position. A soldier carrying a Panzerfaust waits behind a building, trench, or other cover. He cannot open fire from a kilometer away, not even from several hundred meters. He has to wait. The tank comes closer. 100 meters, 80, 60, depending on the model. Only now is the Panzerfaust operator within a realistic engagement range. In such situations, the psychological effect of the Panzerfaust could be significant for both sides. For the German soldier, it provided an opportunity to fight a tank without a heavy anti-tank gun. For the enemy tank crew, it meant that almost any ruin, window, trench, or edge of a forest could conceal a soldier carrying a weapon capable of destroying their vehicle. The Panzerfaust was particularly dangerous in built-up areas. In cities, tanks had restricted room to maneuver, visibility could be poor, and enemy soldiers could approach armored vehicles while remaining under cover. During the final months of the war, this became particularly important on German territory itself. As the Red Army approached Berlin in 1945, Panzerfausts were issued not only to the Wehrmacht and Waffen-SS, but also to Volkssturm formations. The Volkssturm was a people's militia created during the final stages of the war and included men from age groups that would not normally have belonged to regular frontline formations. The simplicity of the Panzerfaust made it one of the few weapons with which such a rapidly trained defender could, at least in theory, pose a serious threat to a Soviet tank. During the Battle of Berlin, Red Army tanks had to operate in an environment well suited to short-range anti-tank weapons. Streets, buildings, basements, and ruined city blocks provided defenders with countless places to hide. A tank's strong frontal armor did not solve every problem either. If a Panzerfaust operator could fire against the side or rear of a vehicle, its armor was often considerably weaker. Depending on the model, the shaped charge warhead of the Panzerfaust was capable of penetrating a very substantial thickness of armor plate. Later versions are commonly credited with penetration in the region of approximately 200 millimeters under ideal conditions. Actual battlefield conditions were, of course, much more complicated. The angle of the armor, location of the impact, distance to the target, and the operator's ability to hit a moving vehicle all affected the result. A Panzerfaust, therefore, did not automatically mean the destruction of a tank with every shot. Its short range remained an enormous limitation. Firing the weapon also presented dangers. The Panzerfaust produced a powerful blast behind the tube. Sufficient clear space was required behind the weapon, and it could not safely be treated like an ordinary rifle when firing from a confined room. The operator also had to survive the enemy infantry. Tanks generally did not fight alone. They could be protected by infantry, whose job included preventing precisely these kinds of close-range anti-tank attacks. The Panzerfaust operator, therefore, had to get close enough to the tank without first being detected and shot by the soldiers protecting it. Despite these limitations, the weapon was an extremely successful solution to a specific problem. Germany manufactured Panzerfausts in the millions. The scale of production demonstrates how important close-range anti-tank defense had become during the final stages of the war. The Panzerfaust is sometimes confused with another German weapon, the Panzerschreck. They were not the same weapon. The Panzerschreck was a reloadable rocket launcher whose basic concept resembled the American bazooka. The Panzerfaust was a considerably simpler disposable system. That simplicity was one of its most important advantages. The influence of the Panzerfaust did not end in 1945. The concept of a lightweight, man-portable anti-tank weapon using a shaped charge warhead continued to develop after the war. The basics. Idea represented by the Panzerfaust can be seen as part of a much broader development in which defeating a tank no longer necessarily required a large anti-tank gun. This permanently changed the environment in which tanks operated. A tank could weigh tens of tons, carry heavy armor, and mount a powerful cannon. But at close range, a single concealed infantryman could still represent a deadly threat. That is why the Panzerfaust earns the number 9 position on our list. It was not Germany's most technologically complicated weapon. Quite the opposite. Its danger came from how simply it solved one of warfare's most difficult problems. How do you give an ordinary infantry soldier the ability to stop a tank? The German answer was the Panzerfaust. Cheap, simple, short-ranged, and extremely dangerous. Number 9. The Panzerfaust. Next, we move to a weapon whose distinctive sound many Allied soldiers learned to recognize immediately. Its enormous rate of fire made it one of the most famous machine guns of the Second World War. Number 8, the MG-42. Number 8, the MG-42. If there is one German infantry weapon that can be recognized almost entirely by its sound, it is the Maschinengewehr 42. the MG-42. Its extremely rapid rate of fire produced a sound in which individual shots could become difficult to distinguish. But the reputation of the MG-42 was based on much more than its intimidating sound. It was an effective, relatively simple to manufacture, and exceptionally fast-firing general-purpose machine gun that became one of the most important weapons of German infantry during the later stages of the war. The MG-42 entered service in 1942. It was developed partly to replace and supplement the earlier MG-34 machine gun. The MG-34 had been an extremely advanced weapon for its time, but it was relatively slow and expensive to manufacture because its production required extensive machining. Germany needed a weapon that could be manufactured faster and in greater numbers. The design of the MG-42 made extensive use of stamped steel components and spot welding. This significantly simplified production. The result was a machine gun that was more efficient to manufacture while remaining extremely capable on the battlefield. The MG-42 fired the same 7.92 57mm Mauser cartridge used by several other German military weapons. But the characteristic that immediately made the MG-42 famous was its rate of fire. A typical cyclic rate was around 1,200 rounds per minute, although the actual rate varied between weapons and conditions and could be even higher. That meant approximately 20 rounds every second. By comparison, many other machine guns of the period fired considerably more slowly. At such a high rate of fire, the sound of individual shots blended almost together. The result was a ripping, almost continuous noise. This distinctive sound became a major part of the MG-42's legendary reputation, but the enormous rate of fire also created a problem. The weapon consumed ammunition extremely quickly. If the gunner simply held down the trigger continuously, a 50-round belt could disappear in only a few seconds. For this reason, the MG-42 was not normally intended to be fired in long, uninterrupted bursts. Crews were trained to use short, controlled bursts. This conserved ammunition and prevented the barrel from heating unnecessarily quickly. Barrel heating was nevertheless an unavoidable problem for any machine gun operating at a high rate of fire. The MG-42 incorporated a highly practical solution. Its barrel could be changed rapidly. A mechanism on the side of the weapon allowed the hot barrel to be removed and replaced with another in a very short time. A trained crew could perform the change within seconds. This was critically important during prolonged combat. A machine gun team could continue fighting by rotating heated barrels instead of having to leave the entire weapon idle while it cooled. The MG-42 was belt-fed. It could be fired from a bipod, in a more mobile role or mounted on a heavier tripod, creating a stable machine gun position for sustained fire. This made it a genuine general-purpose machine gun. The same basic weapon could accompany an infantry squad during an attack, defend a trench, or operate from a prepared position against targets at considerably greater distances. The machine gun occupied an exceptionally important position in German infantry tactics. In some other armies, riflemen could be regarded as the core of a squad with a light machine gun providing support. German organization often approached the problem in effectively the opposite way. The machine gun provided a large proportion of the squad's firepower, while the other soldiers supported the operation of the machine gun team. The MG-42 was therefore not simply another weapon within the squad. It was a central component of German infantry tactics. A typical MG-42 was also not a one-man weapon, in the sense that its gunner carried everything required to keep it operating. The machine gun team included other soldiers who carried ammunition, spare barrels, and additional equipment. This was essential. The MG-42's enormous rate of fire meant that large quantities of ammunition were required. Imagine an Allied infantry unit advancing across an open field toward a German defensive position. A German MG-42 is positioned at the edge of a forest or inside a building. The first short burst can send dozens of bullets across the route of advance within seconds. Even if the fire does not directly strike every soldier, its effect on the attack can be enormous. The soldiers take cover. The advance stops. Other German troops now have greater freedom to maneuver, change position, or open fire. This is one of the fundamental purposes of a machine gun, preventing enemy movement and forcing opposing soldiers to remain under cover. The MG-42's rate of fire made it extremely effective in this role. During the fighting in Normandy in 1944, Allied forces encountered MG-42 machine guns in German defensive positions. In terrain dominated by hedgerows, villages, and prepared positions, a well-placed machine gun could control routes of advance and inflict serious casualties. The MG-42 was also used on the Eastern Front, in Italy, and virtually everywhere German ground forces fought after the weapon entered service. Despite its reputation, the MG-42 was certainly not perfect. Its high rate of fire meant enormous ammunition consumption. Ammunition belts, spare barrels, and other equipment increased the load that its crew had to carry. Nor could the weapon win a battle by itself. A machine gun position could be destroyed by artillery, mortars, tank fire, or an infantry flanking attack. Once the enemy identified the position of the machine gun, it naturally became an important target. The MG-42 gunner was one of the most dangerous soldiers facing the enemy, and therefore also one of the soldiers the enemy wanted to silence as quickly as possible. The weapon's extremely high rate of fire did not automatically make it superior to a slower-firing machine gun in every situation. Fire discipline, crew training, position selection, and sufficient ammunition supplies were at least as important. But in the hands of a skilled crew, the MG-42 was extremely dangerous. Its technical design was also successful enough that its influence continued after the war. West Germany later adopted the MG-3 machine gun, a weapon strongly based on the MG-42 design, but converted to fire the NATO standard 7.62 Tex 51mm cartridge. The MG-3 and its variants went on to serve for decades with the armed forces of numerous countries. The legacy of the MG-42 can therefore be seen very clearly long after the Second World War ended. That is one reason the weapon remains so famous today. The MG-42 was not an experimental wonder weapon. It was not an enormous artillery piece or a technologically futuristic missile. It was a practical infantry weapon designed for mass production and real frontline service. And in that role, it succeeded. It was relatively light for a general-purpose machine gun, it could perform several different roles, its barrel could be replaced quickly, and its firepower was enormous. When an MG-42 opened fire, its distinctive sound immediately warned the enemy that there was a machine gun position ahead and that advancing against it could be deadly. Its effectiveness came not only from the bullets themselves, but from its ability to dominate areas with fire. A single, well-positioned machine gun could stop an infantry advance and force the attacker to change his plan. That is why the MG-42 earns its place on this list. Its sound was intimidating. Its rate of fire was exceptional, but most importantly, behind those characteristics was a well-designed and practical weapon system. Number 8. The MG-42. Next, we leave the ground and move into the sky. During the early years of the war, its silhouette appeared above the battlefields of Poland, France, and beyond. As it dived toward its target, some of these aircraft used sirens whose terrifying howl became one of the sounds associated with Germany's blitzkrieg. Number 7. The Junkers Ju-87 Stuka. Number 7. The Junkers Ju-87 Stuka. Few aircraft of the Second World War are associated so strongly with a single sound as the Junkers Ju-87. When a Stuka began its steep dive toward a target, sirens fitted to some aircraft could produce a howling sound that reached the ground before the bomb struck. The siren became known as the Jericho Trompete, the Jericho trumpet. Its purpose was to increase the psychological impact of the attack, but the danger of the Stuka was based on much more than a frightening sound. The Junkers Ju-87 was designed primarily for accurate dive bombing. The idea was simple. During conventional level bombing, An aircraft flew over its target and released its bomb from altitude. The trajectory of the bomb was affected by the aircraft's speed, altitude, wind, and many other factors. Hitting a small target could be difficult. The dive bomber approached the problem differently. The Stuka could enter a steep dive, almost directly toward its target. This allowed the pilot to keep the target in his sights during much of the attack and release the bomb considerably closer to it than during conventional high-altitude level bombing under the conditions of its time. This made the Stuka a highly accurate bombing aircraft. The history of the Ju-87 began before the Second World War. Its first prototypes flew during the mid-1930s, and the Stuka gained combat experience in the Spanish Civil War as part of Germany's Condor Legion. When Germany invaded Poland in September 1939, the Ju-87 was already an important component of the Luftwaffe's offensive power. It was during these early years of the war that the Stuka built its reputation. In Poland, Norway, France, and elsewhere in Europe, Stukas attacked bridges, artillery positions, troop concentrations, transportation routes, and other tactically important targets. The Stuka was well suited to Germany's operations during the early stages of the war. As German armored forces advanced rapidly on the ground, the Luftwaffe supported their movement from the air. When ground forces encountered a strong defensive position or another obstacle, aircraft could be directed against it. The accuracy of the Stuka made it particularly useful for this mission. It could function almost like highly mobile artillery in the sky, but the Stuka was not a small aircraft. It carried a crew of two, a pilot and a radio operator who also served as the rear gunner. One of the aircraft's most recognizable features was its fixed landing gear. Unlike many faster military aircraft, the Stuka's wheels did not retract into the fuselage during flight. Its wings also had a distinctive inverted gull shape. Different versions of the Ju-87 used different engines and weapon loads, meaning performance figures varied depending on the model. One of the best-known wartime versions was the Ju-87D. The Stuka could carry a bomb load whose size depended on the mission, aircraft version, and required range. In a typical attack configuration, a large bomb could be carried beneath the fuselage with smaller bombs under the wings. Perhaps the Stuka's most interesting technical characteristics, however, were connected with the dive itself. Dive bombing placed enormous stresses on both the pilot and the aircraft. During an attack, a Stuka could descend toward the ground at an extremely steep angle. After releasing the bomb, the pilot had to pull the aircraft back into level flight. During this stage, the crew experienced powerful G-forces. The Ju-87 incorporated an automatic dive recovery assistance system. Its purpose was to reduce the danger of the aircraft continuing uncontrollably toward the ground if, for example, the pilot became temporarily incapacitated by the high G-forces. The Stuka's bomb mounting was also designed so that the bomb carried beneath the fuselage would swing clear of the propeller's path when released. All of this demonstrates just how specialized the aircraft was for the dive bombing mission. During the early stages of the war, that specialization appeared extremely successful. A soldier on the ground might first see the aircraft roll into its dive. Then came the howl of the siren. The aircraft rapidly grew larger in the sky. Moments later, the bomb was released. The psychological impact of such an attack is easy to understand. The Stuka's siren became one of the most recognizable sounds associated with blitzkrieg. It is important, however, not to exaggerate the significance of the siren. It was not used on every Stuka throughout the entire war, and sirens were later removed from some aircraft because of the aerodynamic drag they created, and other practical considerations. The Stuka's real military value came from its ability to deliver bombs with relatively high accuracy against tactical targets. But its reputation concealed a serious weakness. The Stuka performed best when the Luftwaffe controlled the air or could at least protect the dive bombers from enemy fighters. When that protection disappeared, the Stuka's weaknesses quickly became apparent. It was not particularly fast. It was not an agile fighter. Its fixed landing gear created additional drag, and against a modern enemy fighter, the Stuka was in a difficult position. This became especially clear during the Battle of Britain in 1940. Stukas were used in attacks against British targets, but they suffered losses to British Hurricane and Spitfire fighters against a well-organized fighter defense. The Stuka required fighter protection of its own to survive. This revealed the aircraft's central limitation. The Stuka could be an extremely effective attack aircraft, but it could not operate safely in airspace. Controlled by the enemy, that did not mean the aircraft disappeared. From the war after the Battle of Britain, from it, the Ju-87 continued to serve in the Balkans, the Mediterranean, North Africa, and above all, across the enormous Eastern Front. When Germany invaded the Soviet Union in June 1941, Stukas once again supported rapidly advancing ground forces. They attacked artillery, tanks, vehicles, bridges, and other targets. The enormous distances and scale of the fighting on the Eastern Front continued to provide many missions for the Stuka. One of the most famous Stuka pilots was Hans-Ulrich Rudel. He flew an extraordinary number of combat missions during the war and became one of Nazi Germany's most highly decorated servicemen. Rudel was also the subject of extensive wartime propaganda, meaning claims about his individual achievements need to be treated carefully and assessed against reliable evidence. His name is particularly associated with the later Ju-87G. This version changed the role of the Stuka. The Ju-87G was developed for anti-tank operations and carried two 37mm BK 3.7 cannons beneath its wings. The idea was to attack Soviet tanks from the air and attempt to hit their more lightly armored areas. Such attacks demanded a highly skilled pilot. From the air, a tank was a small target. The aircraft had to fly low, establish the correct attack angle, and score a hit while enemy anti-aircraft weapons could be firing. Back, the Ju-87G nevertheless demonstrates how attempts were made to adapt the Stuka to a changing war even after the original dive bomber concept had lost some of its importance. By 1944, the Luftwaffe faced a completely different situation from the beginning of the war. Allied air power had expanded enormously. Germany suffered shortages of aircraft, fuel, and experienced pilots. The slow Stuka became increasingly difficult to protect from enemy fighters. Its missions were increasingly transferred to other aircraft, including ground attack versions of the Focke-Wulf FW-190. The era of the Stuka as one of the Luftwaffe's principal attack aircraft was coming to an end, but its historical reputation had already been established. The Ju-87 had participated in the war almost from its opening days. Its appearance was instantly recognizable. Its dive-bombing tactics were dramatic, and the howl of its siren became a symbol of an entire method of warfare. This makes the Stuka a fascinating example of a weapon whose intimidating reputation was created by both genuine military capability and psychological effect. When it possessed air superiority, sufficient fighter protection, and a suitable target, the Stuka could be extremely effective. When those conditions disappeared, its vulnerability quickly became apparent. The Stuka was therefore not an invincible wonder weapon. Its success depended on the military system operating around it. But during the early years of the war, that system operated with devastating effectiveness. Tanks advanced on the ground, infantry followed, and ahead of them or above them, Stukas struck the targets, threatening to stop the advance. That is why the Junkers Ju-87 earns the number 7 position on our list, not because it was the best aircraft of the war, but because, under the right conditions, it combined accuracy, close support of ground forces, and an extraordinary psychological effect in a way that the enemy quickly learned to recognize. Number 7. The Junkers Ju-87 Stuka. Next, we return to the ground, but our next weapon was originally designed to fire into the sky. It proved so effective, however, that German forces also turned it against one of the most dangerous targets on the battlefield: tanks. Number 6. The famous German 88mm Flak gun. Number 6. The 8.8 centimeter Flak. Among the most famous German weapons of the Second World War is a gun whose reputation was built partly in a role for which it had not originally been primarily designed. The Germans called it the 8.8 centimeter Flak. To Allied soldiers, it became simply the 88. The 88mm Flak was designed as an anti-aircraft gun. Its purpose was to engage enemy aircraft flying at high altitude. But during the war, German forces discovered that the characteristics of the weapon also made it an exceptionally dangerous anti-tank gun. Its high muzzle velocity, powerful ammunition, and long range allowed it to destroy enemy tanks at distances where many conventional anti-tank guns were at a considerable disadvantage. To understand its story, we need to return to Germany after the First World War. The Treaty of Versailles placed severe restrictions on the German armed forces and weapons development. German companies nevertheless continued the development of military technology through various arrangements. Krupp cooperated with the Swedish company Bofors, and this development ultimately contributed to a new generation of German anti-aircraft guns. As Germany rebuilt its armed forces during the 1930s, the 8.8 centimeter Flak became one of the Luftwaffe's important heavy anti-aircraft weapons. The first famous version was the 8.8 centimeter Flak 18. It was followed by the improved Flak 36 and Flak 37. These designations are important because the famous 88 did not refer to one completely identical model of gun. It represented a related family of 88mm anti-aircraft weapons that were developed for different requirements during the war. The original purpose of the weapon was clear. When an enemy bomber was flying at high altitude, the gun had to send a shell thousands of meters into the sky as quickly as possible. That required high muzzle velocity. This same characteristic became decisive when the weapon was lowered and aimed horizontally at a tank. In anti-tank combat, high velocity meant a flatter trajectory and tremendous impact energy. With the appropriate armor-piercing ammunition, the 88mm gun could penetrate the armor of contemporary tanks at considerable distances. That made it extremely dangerous. The weapon also possessed an effective sighting system and a stable mounting. The cruciform mounting of weapons such as the Flak 18 and Flak 36 allowed the gun to traverse through a full circle. For transportation, the weapon was attached to wheeled bogies. In a prepared firing position, these could be arranged to provide a stable platform for the gun. Its crew was large. This was not a weapon that one or two soldiers could quickly move around a battlefield by hand. The gun, ammunition, towing equipment, and crew together formed an entire weapon system. But once an 88 had been positioned effectively and the enemy entered its field of fire, the consequences could be devastating. Its anti-tank reputation began to develop during the early stages of the war. The Battle of France in 1940 brought German forces into contact with heavily armored British and French tanks. The British Matilda II, for example, possessed armor that many conventional German anti-tank weapons struggled to defeat. During the Battle of Arras in May 1940, a British tank attack created a serious situation for German forces. The use of heavy anti-aircraft guns, including 88mm weapons, against the tanks helped stop the attack. This was one of the events that strengthened the 88's reputation as an anti-tank weapon. But the environment in which the legend of the 88 truly grew was North Africa. The desert offered almost ideal conditions for the weapon. Much of the terrain was open. Visibility could extend for enormous distances. In such an environment, a long-range, high-velocity gun could exploit its strengths. German Afrika Korps forces used 88mm guns both for anti-aircraft defense and against ground targets. One effective tactic was to establish prepared gun positions and draw enemy tanks into their fields of fire. Imagine a formation of British tanks advancing across the open desert. German vehicles appear ahead and begin withdrawing. The British continue their advance. Then, far across the horizon, concealed 88mm guns open fire. The tanks can come under attack before they reach an effective firing distance with their own weapons. In such circumstances, the long range of the 88 was an enormous advantage. The gun's reputation is frequently associated with Field Marshal Erwin Rommel and the Afrika Korps. Rommel did not, however, invent the use of anti-aircraft guns against ground targets. The weapon had already been used in this role earlier. The fighting in North Africa nevertheless made the combination famous. The danger of the 88 was not limited to British tanks. On the Eastern Front, German forces encountered Soviet T-34s and heavy KV tanks, especially during the early stages of Operation Barbarossa in 1941. Some standard German anti-tank guns proved inadequate against their armor in certain circumstances. The 88mm Flak provided one effective solution. Its ammunition could destroy even heavily armored tanks from considerable distances. But the 88 was not a perfect anti-tank gun. Its original design as an anti-aircraft weapon created weaknesses when it was used on the ground. It was large. Its high profile made it more difficult to conceal than a low, purpose-built anti-tank gun. Moving it required a towing vehicle. If the enemy discovered the position, the 88 could become a target for artillery, tanks, or aircraft. Its crew was also relatively exposed. A gun shield could provide some protection from the front on certain versions and in certain configurations, but this was not an armored fighting vehicle. An artillery or mortar round exploding nearby could inflict serious casualties on the crew. Effective use of the 88 therefore depended on good positioning, concealment, and a trained crew. When these factors came together, the weapon became extremely dangerous. The original anti-aircraft role of the 88mm Flak never disappeared. Enormous air defense systems were constructed around German cities and industrial areas as British and later American bombers attacked in increasingly large formations. Heavy flak guns fired time-fused shells into the altitudes occupied by the bombers. The objective was to make a shell explode close enough to an enemy aircraft to fill the surrounding air with lethal fragments. A direct hit on an individual aircraft was therefore not necessary. When hundreds of guns fired simultaneously, they created enormous zones of anti-aircraft fire. Allied bomber crews saw black bursts appearing around their aircraft as heavy anti-aircraft shells exploded at their altitude. The Germans even constructed enormous flak towers in cities including Berlin, Hamburg, and Vienna. Heavy anti-aircraft weapons were positioned on these massive concrete structures to help defend the cities against air attack. As the war progressed, the 88mm family continued to evolve. The Flak 41 was a more powerful 88mm anti-aircraft gun offering improved performance against high-altitude targets. At the same time, the reputation of the 88mm caliber extended into tank armament. The famous 8.8cm KK-36 tank gun of the Tiger I shared the same 88mm caliber and was technically connected to the broader developmental background of the Flak weapons, but it should not simply be described as the identical anti-aircraft gun placed inside a tank. Later, the Tiger II used the even more powerful 8.8cm KWK-43, which belonged to a different developmental line. This distinction matters because after the war, the term German 88 easily became a general label for several different 88mm weapons. The original Flak 18, 36, and 37 family earned its reputation primarily through versatility. It could perform the mission for which it had been designed, engaging aircraft at high altitude, but when necessary, the gun could be lowered toward the ground. And then the same high velocity required to reach aircraft became an effective weapon against tank armor. This made the 88 one of the most famous dual-purpose weapons of the war. For an Allied tank crew, detecting one could be difficult before the first shot. A well-concealed gun could open fire from long range. The first indication of its presence might be a shell striking a tank. And because the gun could operate from considerable distance, destroying it was not always easy. Still, the reputation of the 88 should not be transformed into a myth of an invincible weapon. It was large, heavy, and relatively difficult to move. Producing it consumed more resources than smaller anti-tank guns. It required a substantial crew and large quantities of ammunition. and during the final stages of the war, no individual gun could compensate for Germany's diminishing resources or the enormous material superiority of the Allies. But in the right position, with a trained crew and good visibility, the 88 was exceptionally dangerous. It could point toward the sky in the morning and engage tanks later the same day. Few weapons demonstrate more clearly how an application beyond. The original purpose of a design can make a weapon even more famous than its designers may have anticipated. Number 6. The 8.8 centimeter Flak 18, 36, and 37. Next, we move from a gun to an entirely different kind of war machine. In 1943, a new German tank appeared on the Eastern Front, combining a powerful, long-barreled 75mm gun with strongly sloped frontal armor. Its first major battle did not go smoothly, but after many of its technical problems were addressed, it developed into one of the most dangerous German tanks of the war. Number 5. The Panzerkampfwagen 5, the Panther. Number 5. The Panzerkampfwagen, VII Panther. In 1941, Germany's invasion of the Soviet Union brought Wehrmacht armored forces face-to-face with an enemy tank that came as a serious surprise. Its name was the T-34. The Soviet T-34 combined sloped armor, good mobility, and an effective gun in a way that impressed the Germans. Although German armored forces achieved enormous tactical victories in 1941, encounters with the T-34 and heavy KV tanks demonstrated the need for a new generation of German tank. From this development emerged the Panzerkampfwagen VII Panther. The Panther was intended to combine a powerful gun, good mobility, and strong armor. The result became one of the most famous tanks of the Second World War. Depending on the version, the Panther weighed approximately 45 tons. It was therefore considerably heavier than a Panzerfaust, but lighter than a Tiger I. Its crew consisted of 5 men: commander, gunner, loader, driver, and radio operator, who also operated the hull machine gun. One of the Panther's most important characteristics was its armor. The frontal armor in particular was strongly sloped. Sloped armor could provide greater protection than the nominal thickness of the plate alone might suggest, because an incoming projectile had to travel through a greater effective thickness, while the angle could also increase the possibility of deflection. The Panther's upper frontal hull plate was 80 millimeters thick and strongly sloped. This made the front of the tank an extremely difficult target for many Allied anti-tank weapons. But perhaps the most dangerous characteristic of the Panther was its main weapon, the 7.5 centimeter KWK-42L70. Although its caliber was smaller than the famous 88mm gun of the Tiger I, the Panther's 75mm weapon had an extremely long barrel and high muzzle velocity. Using armor-piercing ammunition, it could penetrate enemy armor at considerable distances. This made the Panther especially dangerous in open terrain. A well-positioned Panther could detect an enemy tank at long range, fire before its opponent reached an effective engagement distance, and simultaneously take advantage of its own strong frontal protection. On paper, the combination was excellent: a powerful gun, sloped armor, and good mobility for a tank of its weight. But the story of the Panther also demonstrates the enormous difference between an impressive design and a tank that operates reliably on the battlefield. Germany rushed the Panther into production. Its first major combat deployment came during the Battle of Kursk in the summer of 1943. Operation Citadel was Germany's attempt to attack the flanks of the enormous Soviet salient around Kursk. The Germans assembled large armored forces for the offensive. The new Panthers were expected to form an important part of that strength, but their first major battle revealed serious problems. The Panther was still technically immature. The tanks suffered from engine, transmission, and other mechanical failures. Some Panthers were lost or put out of action without the enemy ever destroying them. This was an enormous problem. A tank can possess excellent armor and an extremely powerful gun, but if it cannot reach the battle or move reliably once there, its combat value collapses. After Kursk, the Panther was continuously improved. The early Panther D was followed by the Panther A and later the Panther G. Many technical problems were reduced, and the Panther gradually developed into a considerably more practical fighting vehicle. It never became completely free of reliability problems. One issue involved its complicated drivetrain and suspension. The tank used large interleaved road wheels. This system helped distribute weight and provided good ride characteristics over difficult terrain, but it was also complicated to maintain. Mud, ice, and snow could accumulate between the wheels. If an inner road wheel was damaged, replacing it could require removing outer wheels first. Under frontline conditions, such complexity was a significant disadvantage. The Panther's side armor was also considerably weaker than its impressive frontal protection. This meant the tank was far more vulnerable when the enemy managed to engage it from the side. Using the Panther effectively, therefore, required good tactical positioning. Its strong front needed to face the principal threat in open terrain, and at long range, this could make the Panther an extremely difficult opponent. In close combat, inside towns, or whenever the enemy could attack from several directions, its advantages became less decisive. In 1944, Panthers encountered large numbers of American M4 Shermans and British tanks on the Western Front. The fighting in Normandy demonstrated both the Panther's strengths and weaknesses. At long engagement distances, its gun and frontal armor were an extremely dangerous combination. But Normandy's hedgerows, villages, and narrow roads did not always provide long fields of fire. The Allies could also employ artillery, air power, anti-tank weapons, and numerical superiority against German armored forces. The technical performance of an individual tank was only one component of a much larger war. This is extremely important when understanding the Panther's reputation. If we compare only armor and gun performance, the Panther looks extraordinarily impressive. But wars are not decided by specification tables. A tank needs fuel, it needs ammunition, it needs spare parts, it needs a trained crew, and when it breaks down, it needs maintenance personnel and a recovery vehicle powerful enough to move a tank weighing almost 45 tons away from the battlefield. As the war approached its end, precisely these things became increasingly serious problems for Germany. Allied bombing damaged German industry and transportation networks. Fuel shortages became severe. Experienced tank crews were lost and could not always be replaced by men with equivalent training. The Panther was also far more complicated to manufacture than tanks such as the American Sherman or Soviet T-34. Germany manufactured approximately 6,000 Panthers during the war. That was a substantial number, but far fewer than the Allies produced of their principal tank types. The United States manufactured almost 50,000 Sherman tanks. The Soviet Union produced different versions of the T-34 in the tens of thousands. Here we can see two very different approaches to armored warfare. The Panther attempted to concentrate extremely high combat performance into one technologically advanced vehicle. The Allies, meanwhile, were capable of manufacturing enormous numbers of tanks and keeping them operational through vast industrial and logistical systems. This does not mean that every Sherman or T-34 was superior to a Panther in an individual tank duel. The point is that on the scale of an entire war, production, maintenance, and availability were at least as important as the thickness of an individual tank's armor. The Panther's intimidating reputation was created particularly in situations where its crew could exploit the tank's strengths. Imagine Allied tanks advancing across open ground. At the distant edge of a forest sits a concealed Panther. Its frontal armor faces the attackers. The commander identifies the first target. The gunner aims the long 75mm cannon. A shot. The high-velocity armor-piercing projectile races toward its target. If the first enemy tank is destroyed, the others attempt to locate the German tank. But the Panther can fire again. Under these circumstances, its long-range firepower could be devastating. This was not merely theoretical. In the hands of experienced crews, Panthers were capable of inflicting serious losses on enemy armored forces. But the enemy also learned how to fight them. A Panther could be flanked. Several tanks could concentrate against it. Its position could be attacked with artillery. Mines could restrict its movement, and sometimes the Panther could destroy its own combat effectiveness simply by breaking down. The history of the Panther is therefore a useful reminder that the word best is problematic when discussing tanks. In firepower, the Panther was excellent. Its frontal protection was extremely strong. Its mobility was good for its size, but in reliability, maintainability, and simplicity of production, it had significant weaknesses. Despite these problems, the Panther also influenced post-war thinking about tank development. Its combination of a powerful gun, sloped armor, and comparatively good mobility anticipated aspects of the balance later sought in post-war tank designs. The Panther was not Germany's heaviest tank. It did not carry its largest gun, and it was certainly not its most reliable. But when an operational Panther encountered the enemy under conditions that allowed it to exploit its strengths, it was one of the most dangerous tanks on the European battlefield, and that is why it earns its place on our list. Number 5. The Panzerkampfwagen VII Panther. Next, we leave tanks behind for a moment. Our next weapon required no crew to fly it to its target. It was launched toward Britain, and the distinctive sound of its engine caused civilians to look toward the sky. But the most frightening moment could come when that sound suddenly stopped. Number 4. The V-1 flying bomb. Number 4. The V-1 flying bomb. During the summer of 1944, a new kind of sound began to be heard across southern Britain. It was not the engine of a conventional bomber. It was a loud, intermittent, and instantly recognizable buzzing sound that caused people to look toward the sky. The source was a small, unmanned flying weapon with a long pulse jet engine mounted above its fuselage. The British gave it the nickname Buzz Bomb. The Germans knew it as the Fieseler Phi 103. In propaganda, it became the Vergeltungswaffe 1, Vengeance Weapon Number 1, the V-1. But the most frightening moment was not necessarily when its engine could be heard. The most frightening moment could be when it stopped. When the engine of a V-1 cut out above the target area, the weapon descended toward the ground. Only a few seconds might remain before the explosion. The V-1 was one of the most unusual weapons of the Second World War. It was not a conventional aircraft because there was no pilot aboard, nor was it a ballistic missile like the V-2 that would enter service later. In modern terminology, the V-1 resembled an early cruise missile in many respects. It flew through the atmosphere supported by wings and carried its explosive payload toward a predetermined target area without a crew. Development of the V-1 was connected to Germany's attempt to create weapons capable of bombing Britain without requiring large formations of conventional bombers. During the early stages of the war, the Luftwaffe had bombed Britain with aircraft. By 1944, however, the situation had changed completely. Allied air superiority had grown enormously. Germany could no longer conduct bombing operations against Britain on the same scale it had attempted in 1940. A different solution was needed. The V-1 offered a way to send a large explosive charge across the English Channel without risking a pilot's life on every mission. The weapon was approximately 8 meters long with a wingspan of a little over 5 meters. It carried a warhead containing roughly 850 kilograms of explosive. Perhaps the most recognizable feature of the V-1 was its Argus as 014 pulse jet engine. The engine was relatively simple in construction. Its operation depended on rapidly repeated combustion cycles that produced the V-1's unmistakable sound. This was the origin of the British nickname Buzz Bomb. The V-1 was not a supersonic weapon. It traveled at roughly 600 to 650 kilometers per hour. This was extremely important because the V-1 flew relatively low through the atmosphere and its speed was within the capabilities of the fastest fighters of the period. It was possible to defend against it. Stopping it, however, was not easy. The V-1 was controlled by a relatively simple automatic guidance system. Gyroscopes helped maintain its direction and altitude. A small propeller in the nose rotated in the airflow and effectively measured the distance traveled. Once a predetermined number of revolutions had been reached, the system activated a mechanism that caused the V-1 to begin its final descent. This was nothing like the precision of a modern missile. The V-1 could not identify an individual building or alter its route to search for a target. It was an area bombardment weapon. A city such as London was a sufficiently large target. The first V-1s were launched against Britain on June 13, 1944, only 1 week after the Normandy landings. The main large-scale campaign began several days later. Most of the weapons were launched from sites constructed in northern France. The V-1 was positioned on a long launch ramp. A steam-powered catapult accelerated the weapon to sufficient speed for its own engine to continue the flight toward Britain. When V-1s began arriving over the London area, British civilians faced an entirely new type of threat. During a conventional bombing raid, air defenses might detect enemy aircraft and air raid sirens could warn the population. The V-1 was much smaller. It arrived quickly, and there was no pilot aboard who could fear anti-aircraft fire or decide to turn back. The sound of its engine became part of the London summer of 1944. As long as the buzzing continued, people could follow the weapon. When the sound suddenly stopped, the situation changed. The V-1 could begin descending toward the ground. Seconds later, its large warhead might explode in a street, residential building, or another part of the city. This gave the weapon a powerful psychological effect. But the British were not defenseless. A layered defensive system was constructed against the V-1. The first line consisted of fighter aircraft. Fast British fighters such as the Hawker Tempest proved particularly effective at intercepting V-1s. Spitfires, Mosquitoes, and other aircraft were also employed. Shooting down a V-1 in the air presented its own danger. Its warhead contained a large quantity of explosive. If a fighter approached too closely when the V-1 exploded, the attacking aircraft could also be damaged. Pilots therefore attempted to fire from a suitable distance. The campaign against the V-1 also produced one of the most famous interception techniques of the war. Some fighter pilots flew alongside a V-1 and positioned their own wing extremely close to the weapon's wing. The airflow could disturb the V-1, sufficiently to upset its gyroscopic control and send it toward the ground. Physical wing-to-wing contact was not always necessary. It was nevertheless a dangerous technique, requiring extremely precise flying. The second defensive layer consisted of anti-aircraft guns. The British moved large numbers of anti-aircraft weapons into the probable flight paths of incoming V-1s. The effectiveness of these defenses improved dramatically with better radar systems and especially shells equipped with proximity fuses. A proximity fuse could detonate an anti-aircraft shell when it passed sufficiently close to its target. A direct hit was no longer always required. This made intercepting the fast-moving V-1 considerably more effective. The third layer consisted of barrage balloons. Steel cables suspended beneath the balloons created a physical obstacle for low-flying V-1s. Together, these defensive measures increasingly reduced the number of weapons reaching London. The Allies also attacked V-1 launch sites in France. Bombing forced the Germans to modify their arrangements and made maintaining the campaign more difficult. After the Normandy landings, Allied ground forces advanced through France. As they captured the regions containing important V-1 launch sites, continuing the ground-launched campaign against London became increasingly difficult. The Germans did not abandon the weapon. V-1s were also launched from aircraft, Heinkel. He-111 bombers could carry a V-1 and release it while airborne. This allowed attacks to continue after many of the French launch sites had been lost. V-1s were also used against Antwerp and other targets held by the Allies. Antwerp was particularly important. The Allies needed its port to supply their armies as they advanced toward Germany. Using V-weapons against Antwerp was therefore also a strategically understandable attempt to disrupt Allied logistics. But how? Effective was the V-1 in reality? Here we need to distinguish between tactical, strategic, and psychological effects. V-1 attacks killed and wounded thousands of people. They destroyed buildings and forced Britain to devote substantial resources to anti-aircraft guns, fighters, and civil defense. Their psychological effect was real, but they did not change the outcome of the war. The V-1 was too inaccurate to reliably destroy small, precisely defined military targets. Large numbers also failed mechanically, missed their intended target areas, or were destroyed by British defenses. Nevertheless, the weapon was technologically significant. The V-1 demonstrated that an unmanned flying weapon could carry a large explosive payload more than 100 kilometers. That basic idea did not disappear when the war ended. Several countries studied German V-weapons after the conflict. The United States had already developed the V-1-derived Republic Ford JB-2 during the war. During the following decades, cruise missiles advanced enormously. They became faster and more accurate, and their guidance systems became fundamentally different. But historically, the V-1 belongs to the important early stages of this development. There is also a darker aspect of the V-1's history that cannot be ignored. Germany's V-weapons program relied on forced labor. Concentration camp prisoners and other forced laborers were used in V-1 production under inhumane conditions. This is an essential part of the weapon's history. The technological development of the V-weapons cannot be separated from the system in which they were manufactured. The V-1 was therefore a weapon filled with contradictions. Technologically, it represented an important step in the development of unmanned long-range weapons. Militarily, it could cause genuine destruction and force the enemy to commit substantial resources to defense. Strategically, however, it arrived too late and was too inaccurate to reverse the direction of the war. By the summer of 1944, Germany had already lost the initiative on almost every major front. The Allies had landed in Normandy. The Soviet Union was advancing from the east. German cities were under continuous aerial attack. The V-1 could not change any of this, but to a person standing on a London street listening to the approaching pulse jet, grand strategy meant very little. There was only the sound in the sky. The buzzing continued, then it stopped. And somewhere nearby, people knew that an explosion might follow within seconds. That is why the V-1 earns the number 4 position on our list. It combined new technology, a large explosive payload, and psychological terror in a way that made it one of the most recognizable weapons of the war. But the next weapon on our list was completely different. It did not fly unmanned toward a city. It moved across the battlefield on tracks. Its thick armor and 88mm gun created a reputation that has survived to the present day. Number 3, the Tiger I. Number 3, the Panzerkampfwagen 6 Tiger Ausf. Better known as the Tiger I. Few tanks of the Second World War have achieved such a legendary reputation. When the Tiger appeared on the battlefield in 1942, it represented a new kind of threat. It was enormous, heavily armored, and armed with a powerful 88mm gun. For Allied soldiers, even the possibility that Tigers were present could influence how an attack was planned. But the real history of the Tiger is far more interesting than the legend of an invincible German tank. The Tiger was extremely dangerous. It was not invincible. Its development was driven by Germany's requirement for a heavy tank with greater firepower and protection than its earlier armored vehicles. Henschel design was selected for production, and the new vehicle became the Panzerkampfwagen 6 Tiger. It later became known as the Tiger B to distinguish it from the heavier Tiger II. The Tiger thereby weighed approximately 57 tons. By comparison, an American M4 Sherman generally weighed around 30 tons, depending on the version. The Tiger was therefore an enormous vehicle. Its crew consisted of 5 men: commander, gunner, loader, driver, and radio operator, who also operated the hull machine gun. Perhaps the most famous feature of the Tiger was its main weapon, the 8.8 cm Cocker 36 L56, the 88mm. Caliber had already developed a formidable reputation through the anti-tank use of German flak guns. The Tiger's Cocker 36, however, should not simply be described as an anti-aircraft gun placed inside a tank turret. Although there were connections in the developmental, Background and ballistic characteristics of the weapons. The KWK-36 designed for the Tiger was an extremely effective tank gun. Combined with good optics and a trained crew, the Tiger could destroy enemy tanks at long distances. This was one of its greatest advantages. If a Tiger detected an opponent first in open terrain, it could often engage before the enemy reached a favorable firing distance of its own. In addition to its 88mm gun, the Tiger possessed heavy armor. Its frontal hull armor was approximately 100mm thick. Unlike the later Panther, the Tiger did not rely primarily on strongly sloped armor plates. Its protection depended largely on sheer thickness. This made the tank extremely heavy. But in 1942 and 1943, the Tiger's protection presented an enormous challenge to many enemy anti-tank weapons. The Tiger first entered combat on the Eastern Front near Leningrad in September 1942. Its debut was not particularly impressive. The terrain was poor for such a heavy vehicle, and the new Tigers experienced technical problems. This immediately demonstrated one of the tank's central weaknesses. The Tiger was an extremely complicated machine. Its enormous weight placed heavy stress on its drivetrain, suspension, and tracks. When everything worked, it was dangerous. When something failed, repairing or recovering a tank, weighing almost 57 tons, was very different from dealing with a lighter vehicle. The Tiger used large, interleaved road wheels. This helped distribute its enormous weight and provided good ride characteristics. But the system was complicated. Mud, snow, and ice could accumulate between the wheels. Replacing an inner wheel could require the removal of several outer wheels. Under field conditions, this could create a considerable maintenance burden. The Tiger was also so wide that narrower transport. Tracks were used for rail movement, the outer row of road. Wheels had to be removed and the combat tracks exchanged for narrower tracks so that the vehicle could better fit railway transport requirements. This tells us a great deal about the Tiger's size and the logistical complications surrounding it. Maybach gasoline engines powered the Tiger. During its production life, moving nearly 57 tons required enormous amounts of energy. Fuel consumption was high. This became an increasingly serious weakness during the later stages of the war as Germany struggled to provide enough fuel for its armored forces. A Tiger could be mechanically ready for battle, but without fuel, it was simply 57 tons of stationary steel. In combat, however, the situation could be very different. When well-positioned and operated by an experienced crew, the Tiger could be exceptionally dangerous. The accuracy and penetration of its 88mm gun allowed it to destroy enemy tanks at substantial distances. Tigers appeared in Tunisia in late 1942. There, the Western Allies received some of their first experience against Germany's new heavy tank. Tigers were later used on the Eastern Front, in Italy, and across Western Europe. It was in these battles that much of the Tiger legend developed. Among Western Allied soldiers in particular, the Tiger developed a reputation as an almost ever-present threat. There was, however, an interesting problem with this perception. Germany manufactured only around 1,350 Tiger I tanks. That was very few compared with the tens of thousands of Shermans and T-34s produced by the Allies. Not every German tank was remotely a Tiger, but soldiers under combat conditions could not always identify an enemy tank accurately. As a result, other German tanks were sometimes reported as Tigers in Allied accounts. The Tiger's reputation grew larger than its actual numbers. That reputation was not entirely undeserved. Under favorable conditions, heavy Tiger battalions could inflict significant armored losses on the enemy. The Germans commonly organized Tigers into separate heavy tank battalions. These units could be moved to sectors where especially powerful armored support was required. The concept was not to replace every ordinary German tank with a Tiger. That would have been economically and industrially impossible. The Tiger was a specialized heavy tank. Imagine a battlefield on the open Eastern Front. Soviet T-34s are advancing. Far ahead of them, partially concealed in a defensive position, A Tiger is waiting. The Tiger commander identifies the first target. The gunner uses high-quality German optics and aims the 88mm gun. The first shot is fired. If it destroys the leading tank, the remaining vehicles must react, but the Tiger is already preparing to fire again. Long-range engagements were where the Tiger could be at its most dangerous. Its opponent had to close the distance, attempt to flank it, or employ other weapons to destroy it. The Tiger's side and rear armor were less formidable than its frontal protection, although still substantial by contemporary standards, and Allied anti-tank capabilities continually improved. The British 17-pounder was a serious threat to German heavy tanks. Soviet heavy guns and newer tanks also increased the danger. The Americans developed more powerful anti-tank weapons and used artillery, tank destroyers and tanks as part of a broader system. The Tiger was therefore not impenetrable. It could be destroyed, and sometimes destroying one did not require a direct tank duel at all. Artillery.mines.air. Attack mechanical failure, fuel shortages, broken track. Any of these could put a Tiger out of action. During a German retreat, a damaged Tiger could become a particularly serious problem. Recovering it required heavy equipment. If the vehicle could not be repaired or evacuated in time, its crew might have to destroy their own Tiger to prevent it from falling into enemy hands. The Tiger was also expensive and slow to manufacture. It required large quantities of materials and labor. At the same time, the Allies were producing simpler tanks on an enormous scale. This leads to one of the most important questions of armored warfare. During the Second World War, is it better to build a small number of exceptionally powerful tanks, or an enormous number of vehicles that are good enough and easier to maintain? The Tiger was an impressive individual fighting machine, but Germany was fighting an industrial world war against opponents whose combined productive capacity was enormous. A single Tiger might destroy several enemy vehicles in battle, but if the enemy could replace those losses and Germany could not replace its own Tiger, the long-term calculation worked against Germany. The Tiger is also associated with several famous tank commanders. One of the best known was Michael Wittmann. His name is particularly associated with the fighting around Villers-Bocage. In Normandy in June 1944, Wittmann became an important figure in German wartime. Propaganda claims surrounding his and other so-called tank aces' individual victory totals therefore need to be approached critically, and compared with reliable evidence. The effectiveness of the Tiger did not depend on one famous commander. Its real strength came from the combination of its gun, armor, optics, trained crew, and tactically advantageous position. When all these elements came together, the Tiger was extremely dangerous. But when logistics failed, the terrain was unsuitable, or the enemy could exploit its wider superiority, its weaknesses became visible. Production of the Tiger. I ended in 1944 as production of the Tiger II was underway. The Tiger II pushed the same heavy tank concept even further. It was heavier, more strongly armored, and carried a more powerful 88mm gun, but its weight and mechanical complexity were also enormous. The Tiger I nevertheless remained the more iconic machine. Its box-like hull, large turret, and long 88mm gun created a silhouette that remains recognizable around the world. In films, games, and popular culture, the Tiger has become almost a symbol of German armored warfare. The reality was more complicated. It was technically impressive but expensive, extremely well-armed but heavy, well protected but not indestructible, a frightening opponent but too rare to change the strategic outcome of the war. Perhaps this contradiction is exactly what makes the Tiger so fascinating. It appears to be the perfect example of Germany's attempt to create a technologically superior weapon. At the same time, it demonstrates the limitations of that approach. In war, it is not enough for a tank to win a duel. It has to reach the battlefield. It has to remain operational. It has to be supplied with fuel. It has to be repairable, and enough of them. have to be available where they are. Actually needed, the Tiger performed exceptionally well in some of these areas and considerably worse in others. But for an enemy tank crew, watching the Tiger's 88mm gun turn toward their vehicle, that wider strategic picture meant very little. At that moment, the Tiger was one of the most dangerous opponents they could face. That is why the Tiger I earns the number 3 position on our list. Number 3. Panzerkampfwagen. 6 Tiger Ausf. The Tiger I. But 2 weapons remain. The next took warfare into an entirely new technological era. Once launched, there was no approaching engine to hear. A fighter could not catch it. An anti-aircraft gun could not shoot it down during its ballistic flight. And for the first time in history, a long-range ballistic missile was used in war against enemy cities. Number 2, the V-2. Number 2, the V-2. On September 8, 1944, something happened in London that had never before been experienced in warfare. A massive explosion struck the Chiswick area. But this time, nobody had heard a bomber approaching. No air raid warning had announced the attack. There had been none of the distinctive pulse jet sound associated with the V-1. The explosion came with virtually no warning. Germany had deployed a new weapon. Its name was Vergeltungswaffe II, Vengeance Weapon Number 2, the V-2. Technically, the weapon was known as the Aggregate 4, or A4. The V-2 was fundamentally different from the V-1 that preceded it. The V-1 was an unmanned winged flying bomb that could be detected and intercepted by fighters and anti-aircraft guns. The V-2 was a ballistic missile. A rocket engine accelerated it to enormous speed. After powered flight, the missile continued along a ballistic trajectory, climbing into the upper atmosphere before descending toward Earth. During its final approach, the V-2 was moving faster than sound. This made it effectively impossible for the defensive systems of the period to intercept once it was already on its way to the target. Sound could not provide advance warning because the missile arrived at supersonic velocity. The explosion happened first. Only afterward might the sound associated with the missile's arrival be heard. The story of the V-2 had begun years earlier. Germany had experimented with liquid-fueled rockets before the beginning of the Second World War. One of the most famous figures involved in the program was the young engineer Wernher von Braun. On the military side, the German Army rocket program was led by figures including Walter Dornberger. An important research center was constructed at Peenemünde on the Baltic coast. There, German engineers attempted to solve the enormous technical problems involved in constructing a rocket of this scale. They needed a sufficiently powerful rocket engine. They needed a guidance system. They needed a structure capable of surviving enormous acceleration and speed. And all of these systems had to function together in a weapon capable of striking a target hundreds of kilometers away. On October 3, 1942, an A-4 rocket launched from Peenemünde completed a successful flight that demonstrated the basic concept could work. Technologically, this was an extraordinary achievement, but that achievement was transformed into a weapon. The V-2 was approximately 14 meters long. At launch, it weighed roughly 12.5 to 13 tons. Its rocket engine used a mixture of ethanol and water as fuel and liquid oxygen as the oxidizer. The engine generated approximately 25 tons of thrust. After launch, the V-2 climbed rapidly into the sky. Its speed increased to several times the speed of sound. Maximum altitude depended on the trajectory, but on long-range operational flights, the missile could climb to roughly 80 to 90 kilometers. Some experimental A-4 launches reached even greater altitudes. The V-2 was therefore among the first human-built machines to reach altitudes associated with the edge of space. But in 1944, its purpose was not scientific exploration. At its nose was a warhead containing approximately 1 ton of explosive. The V-2 had a range of roughly 300 kilometers, depending on conditions and flight profile. This allowed attacks on cities including London from launch areas in the Netherlands. The V-2's guidance system was advanced for its era, but extremely inaccurate compared with modern missiles. Gyroscopes monitored the rocket's attitude and helped keep it on its intended trajectory. During the powered phase, control systems altered the direction of the rocket. At the appropriate point, engine thrust was terminated. The V-2 then continued toward its target on a ballistic trajectory. Its accuracy was not sufficient to reliably destroy individual small military targets. Like the V-1, the V-2 was better suited to attacking large area targets, particularly cities. Its psychological effect was extraordinary. The V-1 was frightening because people could hear it. The V-2 was frightening for exactly the opposite reason. It could not be heard before impact. There was no time to run for shelter after detecting the missile approaching. No fighter could fly alongside it. No anti-aircraft gun could realistically shoot it down during its ballistic attack. With 1944 technology, intercepting a V-2 in flight was not a practical defensive option. The Allies, therefore, had to attempt to stop the missiles before they were launched. Peenemünde became an important target. The Royal Air Force attacked the I. Peenemünde Research Center in August 1943 during Operation Hydra. The bombing damaged the facilities and delayed the program. The Allies also attacked production, storage, and launch infrastructure associated with the V weapons. The Germans, meanwhile, worked to make the V-2 system mobile. This became one of its dangerous characteristics. The missile ultimately did not depend entirely on enormous permanent launch bunkers. A V-2 could be transported into a launch area using specialized vehicles. The missile was raised vertically onto a mobile launch platform. Its systems were checked. Fuel and liquid oxygen were loaded. Targeting information was entered into the guidance system. The rocket could then be launched, and the unit could move away from the area. Finding and destroying these mobile launch teams was difficult. Beginning. In September 1944, V-2 missiles were launched, not only against London but also against Antwerp and other targets. Antwerp became one of the most important targets of the V-2 campaign. The reason was its port. As Allied armies advanced toward Germany, the port of Antwerp had enormous logistical importance. Fuel, ammunition, food, and other military supplies could enter Europe through the port. Germany therefore attempted to use the V-weapons to disrupt this logistical system. One of the most devastating individual V-2 strikes occurred in Antwerp on December 16, 1944. A V-2 struck the Cinema Rex. More than 500 people were killed. It was one of the deadliest individual strikes of the entire V-2 campaign. But the history of the V-2 has an even darker side. When examining the weapon's technological development, it is easy to focus on its rocket engine, speed, and guidance system. The human cost of its production cannot be ignored. After the bombing of Peenemünde, V-2 production was moved underground to the Mittelwerk facility near Nordhausen. Prisoners from the Mittelbau-Dora concentration camp were used as forced labor. Conditions were horrific. Prisoners worked in tunnels with inadequate food, terrible sanitation, and constant exposure to violence and punishment. Thousands of people died within the forced labor system associated with V-weapons production. This creates one of the darkest paradoxes in the history of the V-2. The weapon was technologically years ahead of its time, yet its production relied in part on a system that treated human beings as expendable labor. The technological significance of the V-2 cannot be separated from this criminal system of production. From a military perspective, the V-2 was also an enormously expensive method of delivering approximately 1 ton of explosives to a target. The rocket was complicated. Its manufacture required sophisticated industry. It consumed valuable materials and propellants. And once launched, it could never be used again. A conventional bomber, by comparison, could carry several tons of bombs on a single mission, and if it survived, fly another mission. The V-2's advantage was that the target had essentially no practical way of intercepting it during the final stage of its flight. Its disadvantages were its cost relative to the explosive payload delivered and its poor accuracy. Germany launched more than 3,000 V-2 missiles against enemy targets during the war. They killed thousands of people, but they did not achieve a strategic victory. Britain did not leave the war. the use of Antwerp's port was not stopped. The Allied advance into Germany continued. The V-2 could not reverse the course of the conflict. From a technological perspective, however, its influence was enormous. When Germany surrendered in 1945, both the United States and the Soviet Union wanted access to German rocket technology, missiles, components, documents, and specialists. Werner von Braun and a group of other German rocket engineers eventually went to the United States. The United States used captured V-2 rockets for testing and research after the war. The Soviet Union also exploited German technology and expertise in its own rocket program. The legacy of the V-2 therefore began to appear in both Cold War missile development and space technology. Von Braun later became one of the most famous figures in the American space program and a key leader in the development of the Saturn V launch vehicle. The Saturn V carried Apollo astronauts toward the moon. The historical connection is extraordinary. Technology developed as a weapon for Nazi Germany and produced partly through the forced labor of concentration camp. Prisoners became one of the technical foundations from which later rocket technology developed. The V-2 changed the concept of how far away a target could be attacked. Before it, long-range strategic attack depended primarily on aircraft. The V-2 demonstrated another possibility. A future weapon could launch hundreds or even thousands of kilometers away, climb into the upper atmosphere, and descend on its target at enormous speed. The V-2 of the Second World War still had a range of only around 300 kilometers, but the principle existed. During the following decades, ballistic missile ranges increased from hundreds of kilometers to thousands. Eventually, intercontinental ballistic missiles appeared. The V-2 carried a conventional explosive warhead. Cold War missiles could carry nuclear weapons. At that point, the significance of the ballistic missile changed completely. The V-2 was therefore not the decisive weapon of the Second World War. It did not save Germany from defeat. It did not destroy Britain's war industry. It did not stop the Allied armies, but it demonstrated the future. The V-1 represented an early step toward the cruise missile. The V-2 represented a step toward the age of ballistic missiles, and that is why the V-2 earns the number 2 position on our list. It was frightening in 1944, but even more significant was what it predicted about the future. A missile capable of climbing almost to space and descending on its target at supersonic speed while contemporary defenses were essentially unable to stop it. Number 2, the V-2. But one weapon remains on our list. It was not a rocket. It was not a tank. And it was not an enormous artillery gun. It was an aircraft. When it appeared in the skies in 1944, Allied pilots faced the world's first operational jet-powered fighter aircraft. Its speed made it a dangerous opponent even for the best Allied piston-engine fighters. Had it appeared earlier, in greater numbers and with greater reliability, its impact on the air war could have been considerably greater. Number 1, the Messerschmitt Me 262. Number 1, the Messerschmitt Me 262. During the final years of the Second World War, Allied pilots began encountering an aircraft over Germany that appeared to break the old rules of fighter aviation. When an American or British piston-engine fighter attempted to pursue it directly, the German aircraft could simply accelerate away at tremendous speed. It was the Messerschmitt Me 262, the world's first operational, jet-powered fighter aircraft. The Germans gave the fighter version the name Schwalbe, swallow. The fighter-bomber version was known as the Sturmvogel, Stormbird. The importance of the Me 262 does not come from changing the outcome of the Second World War. It did not. Its importance comes from demonstrating in actual combat what the future of fighter aviation would look like. Development of the Me 262 began before the Second World War. In 1938, Messerschmitt was given the task of developing an aircraft powered by jet engines. The idea was revolutionary. Almost every combat aircraft of the period used piston engines driving propellers. That technology had developed enormously. By 1944, Aircraft such as the British Spitfire, American P-51 Mustang, and German Bf-109 were extremely capable machines, but increasing the speed of propeller-driven aircraft faced physical and technical limitations. The jet engine offered an entirely different path. The greatest development problem facing the Me-262 was ultimately not the airframe itself. It was the engines. The aircraft was designed with two engines. Production. Aircraft eventually used two Junkers UMO-04 turbojets. They were technologically advanced, but difficult to manufacture. Under wartime conditions, Germany suffered shortages of strategic alloys capable of surviving extreme temperatures. As a result, compromises had to be made in the construction of the engines. This affected their reliability and operating life. The first Me-262 prototype flew in 1941, initially powered by a piston engine because suitable jet engines were not yet available. The first flight powered solely by jet engines took place on July 18, 1942. It demonstrated that the concept worked when the Me-262 finally entered operational service in 1944. Its performance was remarkable. Depending on version and conditions, its maximum speed was approximately 850 to 870 kilometers per hour. It was clearly faster than most operational Allied piston engine fighters. Speed was the Me-262's greatest defense. If a German pilot used the aircraft correctly, an Allied fighter had great difficulty catching it in a direct pursuit. But the Me-262 was not merely fast, it was also extremely heavily armed. Fighter versions were normally equipped with four 30mm Mk-108 cannon in the nose. Even a single 30mm shell could inflict serious damage on an aircraft. When the combined fire of four cannons struck a large four-engine bomber, the results could be devastating. Allied bombers became one of the Me-262's most important targets. By 1944, German airspace was under enormous pressure. American 8th Air Force bombers attacked during the day. RAF Bomber Command attacked primarily at night. German cities, oil facilities, transportation networks, and industrial plants were being bombed continuously. The Luftwaffe needed a weapon capable of penetrating bomber defenses and inflicting heavy damage quickly. The Me-262 was well suited to this mission. Its speed allowed a rapid approach. Its 430mm cannon provided tremendous firepower. Some Me-262s later also carried R4M air-to-air rockets. These small rockets could be fired in salvos against bomber formations, and Me-262 attack could happen extremely quickly. The pilot approached a bomber formation at high speed. He had only a short period in which to aim, then the 430mm cannon opened fire. Within seconds, the jet could pass through the formation and emerge on the other side. Its speed presented a serious problem for Allied fighters, but speed did not make the Me-262 invincible. The Allies quickly developed tactics against it. One of the most effective solutions was to avoid fighting the Me-262 under conditions that favored it. Instead, Allied fighters attacked when the jet was most vulnerable. During takeoff, during landing, or near its airfields. The UMO-004 engines responded more slowly to throttle changes than piston engines. Pilots had to operate the throttles carefully because rapid changes could cause engine problems. During its landing approach, the Me-262 had to slow down. At that point, its enormous speed advantage disappeared. Allied fighters began patrolling near known Me-262 bases and attempted to attack the jets. During these vulnerable periods, the Germans responded by protecting jet airfields with anti-aircraft guns and conventional fighters. One famous solution involved Focke-Wulf Fu-190D fighters providing protection for Me-262s during takeoffs and landings. This illustrates the Me-262's situation perfectly. At full speed in the air, it was extremely dangerous. Around its airfield, it was much more vulnerable. The engines themselves also remained a serious problem. The UMO-004 was historically significant, but its service life was extremely short compared with later jet engines. Engine life could be measured in only tens of operating hours. and improper handling could shorten it even further. In the hands of an experienced pilot, the Me-262 could be an excellent weapon. But Germany in 1944 and 1945 was running short of exactly those experienced pilots. The Luftwaffe had lost enormous numbers of veterans during years of combat. There was increasingly little fuel or time available to train replacements. This created a strange situation. Germany possessed one of the most advanced fighter aircraft in the world, yet it could not always provide pilots with enough training to exploit its full potential. The fuel shortage was an even greater problem. Germany's synthetic fuel plants had become major targets for Allied bombing. During 1944, the fuel situation deteriorated dramatically. Manufacturing an aircraft is useless if there is no fuel available to fly it. The same applied to spare parts, maintenance and airfields. Allied aircraft attacked German air bases, railways, and production facilities. The Me-262 was therefore operating while the entire military system surrounding it was beginning to collapse. One of the most debated questions surrounding the Me-262 concerns Adolf Hitler. A frequently repeated story claims that Hitler decisively delayed the aircraft by demanding that it be turned into a bomber instead of a fighter. The reality is more complicated. Hitler did want the Me-262 used as a fast bomber, and this affected priorities within the program. But the delays cannot be explained by that decision alone. Engine development and production difficulties were crucial factors. The Jumo 004 simply was not ready for reliable large-scale operational use. Earlier, the claim that Hitler alone prevented fleets of combat-ready jet fighters from entering service at a decisive moment therefore oversimplifies the history. Both fighter and fighter-bomber versions of the Me-262 were produced. The aircraft was also used for reconnaissance, and two-seat night fighter versions were developed late in the war. One of the most famous Me-262 units was Jagdverband 44. It was led by Adolf Galland, one of the Luftwaffe's best-known fighter pilots. Several highly experienced pilots were gathered into this unit during the final months of the war. They demonstrated just how dangerous the Me-262 could be in skilled hands. But by then, it was already too late. Allied aircraft filled the skies in enormous numbers. German airfields were being bombed, fuel was scarce, training new pilots was increasingly difficult. Industry and transportation networks were under continuous attack. The production total of the Me-262 appears more impressive on paper than its actual battlefield presence. Approximately 400 Me-262s were built. Not all of them ever entered operational combat. Some were destroyed on the ground. Some waited for engines, fuel, or other components. Others suffered technical failures. The number actually available for operations was therefore considerably smaller than the total number manufactured might suggest. Nevertheless, Me-262s achieved aerial victories. German jet pilots successfully shot down Allied bombers and fighters. Estimates of the exact total vary, and wartime claims should not automatically be treated as confirmed victories. What is clear is that the Me-262 was a genuine and dangerous combat weapon. At the same time, we should avoid one of the most common alternative history claims surrounding the Second World War. If the Me-262 had appeared a year earlier, could Germany have won the war? Probably not. A single fighter type could not solve Germany's strategic problems. By 1944, the Allies possessed overwhelming industrial superiority. They could manufacture aircraft, train pilots, and replace losses on a scale Germany could no longer match. They also controlled an increasing proportion of European airspace. In the East, Soviet armies were advancing toward Germany. In the West, Allied armies had landed in France. Germany's fuel system was in crisis. The Me-262 could not solve these problems by itself. Technologically, however, its significance was enormous. When the Allies examined captured Me-262s after the war, they could see clearly that jet propulsion represented the future of fighter aviation. Jet aircraft had also been developed elsewhere. The British Gloucester Meteor was operational during the war as well. The Meteor and Me. 262 never fought each other in aerial combat. The Me. 262's special historical position comes from becoming the first operational jet-powered fighter in the first jet fighter to see air-to-air combat. After the war, fighter development among the major powers rapidly shifted toward jet propulsion. Within only a few years, the age of the piston engine fighter began to fade. Speeds increased. Operating altitudes increased. Aerodynamics changed. Weapons developed. Eventually, jet fighters approached and then exceeded the speed of sound. The Me-262 stands near the beginning of this enormous technological transition. Even today, its shape appears surprisingly modern. 2 jet engines beneath the wings, a streamlined fuselage, moderately swept wings, heavy armament concentrated in the nose. In 1944, an aircraft like this looked like the future, and in many ways it was. But as with so many advanced German weapons, technological performance could not overcome strategic reality. Germany needed more than a new fighter. It needed fuel. It needed trained pilots. It needed secure airfields. It needed functioning factories and transportation networks. And above all, it needed time. By 1944 and 1945, it no longer had enough of any of them. The Me-262 entered the war as Germany was approaching defeat. Its story is therefore simultaneously one of technological achievement and military failure. It demonstrated that a jet fighter could operate successfully in combat. It could outrun most of its opponents. It could destroy heavy bombers with exceptionally powerful armament. But there were too few of them. Its engines were too unreliable. Fuel was too scarce. Experienced pilots were too scarce. And it arrived too late. The Me-262 did not save the Third Reich, but it did not need to win the war to become historically significant. Because when an Allied pilot first watched a jet aircraft race past at a speed his own propeller-driven fighter could not match, he was also seeing a glimpse of the future. The age of the piston-engine fighter was approaching its end. The age of the jet fighter was beginning. That is why the #1 position on our list belongs to the Messerschmitt Me 262. Not because it was invincible, not because it changed the outcome of the war, but because it combined exceptional speed, heavy armament, and a new form of propulsion in an aircraft that became one of the most dangerous fighters in the world during 1944 and 1945, and a preview of the next era of aerial warfare. #1, the Messerschmitt Me 262 Schwalbe. The world's first operational jet-powered fighter, and one of the most significant German weapons technologies of the Second World War. Our bonus weapon, the Me-262, carried aerial warfare into the beginning of the jet age, but the #1 position on our list belongs to a weapon whose impact did not depend on unprecedented speed or massive armor. Its battlefield was the Atlantic Ocean. Its most important task was to find the enemy before the enemy found it, and under the right conditions, its crew could strike without the target even knowing a submarine was there. #1. The Type VII U-boat. If one submarine type had to be chosen to symbolize Germany's U-boat campaign during the Second World War, the Type VII would be the strongest candidate. It was not Germany's largest submarine. It did not possess the greatest operational range, and by the end of the war, it was not Germany's most technologically advanced design. But the Type VII became the principal combat submarine of the German U-boat fleet and the most numerous German submarine type of the war. More than 700 Type VIIs of the different variants were built. Their crews fought across the Atlantic, the North Sea, Arctic waters, and the Mediterranean, and their principal objective was simple, but strategically enormous: cut Britain's maritime lifelines. Britain was an island nation. It depended on enormous quantities of imported food, fuel, raw materials, weapons, and military supplies. When war began in 1939, Germany understood that defeating Britain did not necessarily require destroying its army in a land battle. If merchant shipping across the Atlantic could be disrupted severely enough, Britain's ability to continue the war could potentially be placed under enormous pressure. The U-boat became one of the principal weapons in this strategy. The Type VII evolved from Germany's earlier submarine experience. The first major production version was the Type VII-A. It was followed by the Type VII, which offered improvements including greater range and performance. The most famous and numerous version became the Type VIIC. It is the VIIC that largely created the image most people today associate with the classic German U-boat. The Type VIIC was approximately 67 meters long. It displaced roughly 770 tons on the surface and more than 870 tons submerged. Crew numbers varied, but typically around 40 to more than 50 men could serve aboard, depending on the stage of the war and the boat's equipment. Space was extraordinarily limited. A Type VII was not a large ship. It was essentially a long metal tube packed with torpedoes, diesel engines, electric motors, batteries, pipes, valves, food, equipment, and human beings. Privacy was virtually non-existent. Men slept in cramped bunks. During long patrols, some sleeping spaces could effectively be shared between men working different watches. Food was stored almost anywhere space could be found. Fresh water had to be conserved. Opportunities to wash were extremely limited. The smells of diesel fuel, oil, sweat, food, and moisture mixed inside the boat, and this could continue for weeks. The Type VII relied on two different propulsion systems. On the surface, it used diesel engines. These allowed the boat to travel relatively quickly while also charging its large batteries. Underwater, the diesels could not operate normally because they required air. The submarine therefore switched to electric motors powered by batteries. This reveals something important about Second World War submarines. They were not true continuously submerged submarines in the modern sense. They were closer to surface vessels capable of diving to attack, hide, or escape. The Type VIIC was considerably faster on the surface than underwater. Its maximum surface speed was around 17 knots. Submerged speed was roughly 7 to 8 knots, and operating at high underwater speed drained the batteries rapidly. U-boats, therefore, spent much of their time on the surface, particularly at night during the earlier years of the war. That was also where they searched for targets. The Type VII's primary weapon was the torpedo. A Type VIIC normally carried 4 forward torpedo tubes and 1 stern tube. It could carry approximately 14 torpedoes. Against a merchant ship, the torpedo was an extremely dangerous weapon. A single hit could cause enormous damage. Several hits could quickly sink even a large vessel. But German torpedoes were not without serious problems. Early in the war, German crews suffered from major torpedo failures. Detonators and depth control systems did not always function correctly. A torpedo could run too deep. It could strike its target without exploding. For a commander, the situation could be infuriating. He might have spent hours or even days maneuvering into the perfect attack position. The torpedo hit, and nothing happened. These problems were gradually addressed, and U-boats became extremely dangerous to Atlantic merchant shipping. How a Type VII attacked depended on the situation. Its commander first had to locate a convoy, determine its direction and speed, reach an attack position, identify suitable targets, calculate the torpedo firing solution, and accomplish all of this without the convoy escorts finding the submarine first. During the earlier stages of the war, one of the most effective tactics was a nighttime surface attack. In darkness, the low silhouette of a U-boat was difficult to detect. On the surface, it was also considerably faster than underwater. A commander could attempt to penetrate the convoy itself and fire torpedoes from relatively close range. It was dangerous, but when successful, the results could be devastating. The Germans also developed what became known as wolf pack tactics, individual U-boats spread across patrol lines in the Atlantic. When one located a convoy, it reported the position by radio. Other submarines were directed toward the area. Several U-boats could then attempt to attack the same convoy. The objective was to overwhelm its defenses. An escort might hunt one submarine. But what happened when several boats attacked from different directions in darkness? During the early years of the war, this strategy inflicted extremely serious losses on Allied shipping. German submariners famously referred to periods of particularly successful operations as the happy time. Merchant ships were being sunk in significant numbers around Britain and across the Atlantic. When Germany declared war on the United States in December 1941, another opportunity appeared. In early 1942, Germany launched Operation Paukenschlag, known in English as Operation Drumbeat. U-boats were sent toward the east coast of the United States. At first, weaknesses in coastal defenses and convoy organization created excellent opportunities for German submarines. Merchant ships could sometimes be silhouetted against lights on shore. For a U-boat commander, the situation could seem almost unbelievable. A target might be clearly visible against the glow of an American city. Heavy merchant shipping losses followed. But the Battle of the Atlantic did not remain this way. The Allies learned, and that changed everything. The convoy system expanded. Destroyers, corvettes, and other escorts protected merchant vessels. Radar improved. Sonar, known to the British as ASDIC, helped search for submarines underwater. High-frequency direction finding, or HFDF, helped locate U-boat radio transmissions. Air coverage expanded across the Atlantic. Long-range aircraft closed areas in which U-boats had previously operated with relative security. Escort carriers brought aircraft into the middle of the ocean. Improved depth charges and other anti-submarine weapons increased the ability to attack submerged boats. The breaking of German Enigma communications also provided the Allies with extremely valuable intelligence at important stages of the campaign. Gradually, the hunter increasingly became the hunted. For the crew of a Type 7, one of the most frightening situations began when an escort detected the boat and forced it underwater. Below the surface, the U-boat's options were limited. It could attempt to escape quietly, but ships above were searching for it. Then came the sound of propellers, and shortly afterward, the depth charges. A depth charge did not have to strike the submarine directly. The pressure wave from an underwater explosion could damage the hull, pipes, valves, batteries, and other systems. The entire boat could shake violently. Lights might fail, water might begin entering the hull. The crew might have no idea whether the next explosion would be closer or farther away. They could only wait in silence. If a boat suffered catastrophic damage deep underwater, the chances of escape were extremely small. This is part of what makes the U-boat war such a brutal chapter of the Second World War. The Type 7 was a dangerous weapon, but it was also an extraordinarily dangerous place for its own crew. German U-boat crews suffered exceptionally heavy casualties during the war. Around 30,000 German U-boat personnel were killed. A very large proportion of the men sent into operational service never returned. In 1943, the Battle of the Atlantic reached its decisive phase. In March, U-boats were still inflicting extremely serious losses on Allied convoys. For a moment, Germany's submarine campaign again appeared capable of becoming a critical threat. But only a few months later, the situation had changed dramatically. May 1943 became a turning point in the U-boat war. The Allied anti-submarine system had become increasingly effective. U-boats were being destroyed at a rate Germany could no longer accept. Admiral Karl Dönitz was forced to withdraw many of his submarines from the North Atlantic convoy routes. This did not end the U-boat campaign, but it meant Germany had lost its best opportunity to win the Atlantic battle using its established methods. The Type 7 continued to evolve during the war. Anti-aircraft armament was strengthened. Radar warning equipment was developed. The introduction of the snorkel eventually allowed diesel engines to operate and batteries to be charged, while the submarine remained just below the surface. But these were responses to a problem that continued to grow. The Allies controlled more and more of the Atlantic. Late in the war, Germany developed the much more advanced Type VII submarine. It was designed to operate far more effectively underwater. If the Type 7 represented the peak of the older U-boat concept, the Type VII Missile pointed toward the future. But the Type VII arrived too late to have a significant effect on the war. The Type 7 had carried the majority of the struggle. Several famous German U-boats belonged to this family. One of the best known was U-47, a Type 70B commanded by Günther Prien. In October 1939, Prien penetrated Scapa Flow, one of the Royal Navy's most important bases. U-47 torpedoed the British battleship HMS Royal Oak. The battleship sank, killing more than 800 men. The attack became an enormous propaganda victory in Germany. It demonstrated that a U-boat could strike even inside one of Britain's most important naval anchorages. But the strategic significance of the Type 7 did not come from individual spectacular attacks. It came from thousands of days spent in the Atlantic, searching for convoys, tracking merchant vessels, launching torpedoes, and maintaining the constant possibility that another cargo ship would never reach Britain. The Battle of the Atlantic was a logistical war. Britain, and later the entire Allied campaign in Western Europe, depended on an enormous maritime transportation system. American troops, vehicles, fuel, ammunition, and food crossed the Atlantic. Without this connection, Britain could not have served in the same way as a base for the eventual liberation of Western Europe. The mission of the U-boats was therefore strategically much greater than sinking individual merchant ships. Germany was attempting to sever an artery that kept the Allied war machine alive. It failed. The Allies built replacement merchant ships on an enormous scale. Convoy defenses improved. Intelligence improved. Anti-submarine technology improved. And American industrial capacity transformed the entire material equation. Germany could sink ships, but ultimately it could not sink them fast enough to overcome Allied replacement capacity and destroy the Atlantic transportation system. At the same time, every U-boat lost meant the loss of a trained crew. As the war progressed, the exchange became catastrophic for Germany. The story of the Type 7 is therefore full of contradictions. It was a relatively small vessel with a strategic mission. It used technology whose basic principles existed before the war, yet it could threaten the maritime lifelines of a major power. It could sink a large cargo ship with a few torpedoes, but an aircraft, destroyer, or corvette could ultimately destroy the submarine and everyone aboard. And that is why the Type 7 takes the #1 position on our list. Not because it was Germany's most futuristic weapon. The V-2 and Me-262 were far more revolutionary in that sense. Not because a single Type 7 was as visually imposing as a Tiger or Panther, but because the Type 7 formed the backbone of one of Germany's most dangerous strategic weapons systems. Hundreds of submarines, thousands of patrol days, torpedo attacks across an enormous ocean, and a campaign lasting years to sever the vital Atlantic supply routes. At moments, the threat became serious enough that the outcome of the Battle of the Atlantic had enormous implications for the entire war in Europe. Ultimately, the Type 7 lost its battle, but defeating it required an enormous system. Convoys, warships, aircraft, radar, sonar, intelligence, code-breaking, new weapons, and massive industrial production. An individual Type 7 was only a submarine approximately 67 meters long, but together, hundreds of them forced the Allies to build an entire war machine dedicated to hunting them. That alone demonstrates how seriously the threat was taken. #1. The Type 7 U-boat, the workhorse of Germany's submarine campaign, and one of the most feared weapons of the Battle of the Atlantic. Those were the stories of 10 of the most feared and famous German weapons of the Second World War, with the Messerschmitt Me 262 included as our bonus weapon, showing the direction in which aerial warfare was already beginning to move. The VII weapons on this list ranged from the Panzerfaust carried by an individual infantryman to heavy tanks, long-range missiles, and submarines operating beneath the Atlantic. Some of them were technologically ahead of their time. The Sturmgewehr 44 demonstrated what the future infantry weapon could look like. The MG-42 combined an extraordinary rate of fire with the practical concept of a general-purpose machine gun. The Panzerfaust gave an ordinary soldier the ability to pose a serious threat to a tank. The Stuka made dive bombing one of the most recognizable features of the early years of the war. The 88mm Flak demonstrated how a weapon designed for anti-aircraft defense could become an extremely effective anti-tank gun. The Panther and Tiger were dangerous opponents whenever their crews could exploit their firepower and protection. The V-1 and V-2 pushed long-range strike weapons in an entirely new direction, and the Type 7 U-boat threatened the vital Atlantic supply routes for years. But the most important conclusion from this video is not that Germany could have won the war simply by building more weapons like these. The reality was the opposite. The war demonstrated that a single advanced weapon does not decide the outcome of a global conflict. A weapon needs fuel, ammunition, spare parts, trained crews, functioning factories, transportation networks, maintenance, intelligence, and above all, an enormous industrial system capable of replacing losses faster than the enemy can inflict them. By 1944, Germany was suffering from severe fuel shortages, the loss of experienced personnel, continuous aerial attacks, and increasing shortages of materials. At the same time, Allied production capacity was enormous. The United States, the Soviet Union, Britain, and the other Allied powers could manufacture aircraft, tanks, ships, ammunition, and vehicles on a scale Germany could no longer match. This is where the difference between technological performance and strategic reality becomes most obvious. A Tiger might win an individual tank duel, and Me-262 might outrun an enemy fighter. A V-2 could not realistically be intercepted as it approached its target. A Type 7 might sink a merchant ship in the middle of the Atlantic, but none of them could win the war by themselves. Even so, their historical importance remains enormous. Many of the technologies represented by these weapons influenced military development after the war. Assault rifles became standard infantry weapons around the world. Jet engines replaced piston engines in fighter aircraft. Ballistic missiles eventually developed into intercontinental weapon systems. Submarines became increasingly capable of operating continuously underwater. And portable anti-tank weapons continued to give individual infantrymen the ability to threaten heavily armored vehicles. German weapons of the Second World War were therefore full of contradictions. Some were extremely effective, some were too complicated, some were too expensive, some arrived too late, and some predicted the future far more successfully than they influenced the war in which they were created. But each of them tells us something about the development of warfare. And perhaps that is why they are still discussed more than 80 years later. Which of these weapons do you think was the most impressive? Was it the Tiger WWII, the V-2, the Me-262, or the Type VII U-boat that hunted Atlantic convoys for years? Tell me your choice in the comments. If you enjoyed this video, leave a like and subscribe to the channel, because more long-form documentaries, top 10 countdowns, and stories from the most famous battles, soldiers, and weapons of the Second World War are coming soon. Thank you for watching, and I'll see you in the next video.